Hey guys, welcome to another Kubernetes hands-on training video. This one is about Kubernetes admission webhooks. We're gonna look at what they are and what they do for us. We're gonna look at Kubebuilders and its amazing scaffolding power that help us generate a bunch of manifests and code to create our own first admission webhook. If you're new to Kubebuilder, please check out my Kubebuilder crash course. I will put the link in the description, or we can find it somewhere on top of this video. And also I've marked it as the main video of my YouTube channel. You can easily find it. Let's dive right in. This is the agenda that we're going to cover. We're going to start by talking about the admission controllers, which are plugins for the Kubernetes API server. Then we're going to talk about the dynamic admission control, which basically enables developers to build their own custom admission logic. And we're going to create our first webhook, implement our mutation and validation logic, obviously deploy it to our Kubernetes cluster in this environment, and then test our mutation and validation logic. All right, so what are admission controllers? An admission controller is a piece of code that intercepts requests to the Kubernetes API server after the authentication and authorizations are done and before persisting the object to the Kubernetes database or etcd. Admission controllers can be validating, mutating, or both. A mutating admission controller, you can think of like a request is coming in, it looks at the field set on the request and adds some new field or change the value of something or append something to some field, basically mutates the object. Maybe like in the case of update, we want to set the last update timestamp on the resource before saving it to the database. You can implement that logic with a mutating webhook. Validating webhook, look at the resource and decide whether or not to reject the resource before passing it to the Kubernetes API server. We have a list of admission controllers that are developed by the Kubernetes project, the Kubernetes API machinery to be precise. How can we make sure that which ones are enabled for us and which one are not, depending on your Kubernetes setup? You can check out the value for the enable admission plugins option of your Kube API server. For example, in this environment, I have this kubeadmin sort of environment. If I look at this YAML file and if I scroll up to the enable admission plugins, I see that I have node restrictions enabled for this cluster. So that basically means this one, in addition to the ones that are enabled by default, are now active in my cluster. Now let's go ahead and look at the dynamic ones. So in addition to the compiled plugins that we saw in the previous part, we can have a dynamic admission control mechanism, and that is enabled by these two, let's go back to the previous slide, by these two admission controllers. So it enables us to build our own webhook for implementing our own custom mutation and validation. What do we mean? So basically we create a webhook, we create an HTTP server. To be super simple, this HTTP server is going to talk to the Kubernetes API server. This is sort of a callback. Kubernetes API server asks this guy, do you want to mutate this, or is this valid? And our webhook will come up with an answer. Admission webhooks, the webhooks that we implement can run inside the cluster or outside. We don't necessarily have to run them inside the cluster, but if we, for example, run them inside the cluster, we can use Kubernetes native tools like Cert Manager for automatically injecting SSL certificates into our webhooks, which makes the communication between our webhook and the Kubernetes API server secure. Let's look at this diagram. You can obviously check out this link to read more about it, but let's look at the image, and I'm gonna zoom in a bit. So this is the flow. This is the user, either creates, updates, or deletes a resource. The request is sent to the Kubernetes API server. Authentication and authorization is done. Then we have the dynamic admission controller. Dynamic admission controller will call the mutating webhooks first, because it makes sense to first call all the mutation logic and then do the validation, because we don't want to mutate after we have validated the object. So the mutation logic will be called. The communication with our webhook will happen via this object, through this object admission review request, and our webhook will come up with an answer with admission review response. This response includes like a patch of mutation to the resource if there is any mutation needed. Then we have the schema validation, which, as you might remember, from the OpenAPI schema of CRD API. We have an OpenAPI schema, and we can basically tell our declarative API that, okay, for example, this field needs to follow a certain regular expression pattern, or should be at least should have a minimum value of X or maximum value of Y. So this kind of schema-based validation happens after the mutation webhook, and then we have the validation webhook. So again, same object, request response, and our validation webhook, and then finally, when all this flow is through, we're gonna persist the data to the etcd database. All right, before we start creating our first webhook, let's install some dependencies. We're gonna start by installing Kubebuilder. Go finally K9s to easily navigate through our Kubernetes cluster. All right, we're gonna pick up where we left off last time by cloning our ghost operator tutorial. This is the repository for the ghost operator tutorial. Let's clone that and cd into that directory. From now on, I'm gonna switch to the editor tab. Let's close this workspace first and open our operator tutorial folder, and let's install a bunch of stuff. Go syntax highlighting and YAML to have some syntax highlighting for the YAML files as well. Good. So where are we now? We are in the operator tutorial. Cool. Kubebuilder, just like the APIs, it has a command line tool for creating webhooks. You need to introduce your GVK or group version kind, and these two options will tell the webhook that what kind of webhook it's gonna be. Basically, defaulting will create a defaulting webhook for us. That means it's a mutating webhook to set the defaults on our custom resource. And programmatic validation is a logic that is going to be executed when we want to validate our custom resource, or basically is the logic of our validating webhook. So let's run this, and it automatically runs the make generate. Let's give it some time. All right, it's done. And now let's have a look at what Kubebuilder scaffolding has created for us. We have now inside our API v1 directory, we have ghost webhook and one test suite for our webhook. So we don't need that. We're not gonna implement any tests for our webhook. Let's just get rid of them. This is what you get out of the box, and it is generated for you with empty, let's say with placeholders for your defaulting logic and for your validation logic at the time of creation, update, and deletion. So if we want to implement defaulting or mutating logic, we're gonna implement our logic here. And if we want to implement the validating logic, we're gonna fill these placeholders with the right logic for our validation. Before we do that, we're gonna add a new field to our custom resource. So let's go look at our ghost types file, and we're gonna add a new field to our custom resource called replicas. So I'm gonna simply copy this and paste it in here to the spec of our custom resource and save it. For defaulting, we're gonna set this replicas to a predefined value for the defaulting logic. And at the time of validating our custom resource, we're gonna look at what is set on this replicas field and reject requests that have replicas bigger than, let's say, a certain number. So let's do make manifests now. And when we do make manifests, the CRD that is generated for us, the CRD basis, this is our custom resource definition. As you can see, we have now this new replicas field with some schema-based validation. So basically, this Kubebuilder marker has been translated into this schema-based validation. So this replicas should be of type integer and should at least be 1. So this is the schema-based validation, which we talked about in the previous part. So now let's move on to the next part. All right, so we added a new field called replicas, and we ran make manifest to generate the new manifest and update our CRD. Now we need to update our controller logic so that it can address this replica that is coming from the spec. So we need to go to internal and our controller. We have two places that we need to update. One is in this generate desired deployment spec. So it is in line 245. Find it, it's right here. So we have now by default set it to 1. Let's just replace it with this line. Another place that we need to update is the let's say update condition in our update deployment. So this replica will be the number of replicas for the deployment managed resource, the deployment resource that is being managed by our controller. Here at line 217, we have this if condition, which we're going to replace with this, which basically means we do update our managed deployment whenever the image changes or the replicas field on the spec is changed. So after we do that, let's run make again to make our controller. This will take some time because we're compiling our controller for the first time on this live environment. All right, now we successfully filed our controller. Let's move on to the next part. We updated our controller logic to address this new replicas field. Now we need to implement our mutating or defaulting logic and validation logic. Let's just copy this whole block and go to our webhook. This is what we got out of the box. Let's just select all of this and replace it with this. What do we have here? Let's start from the top. This is our defaulting logic, very simple. If the replicas is set to 0 or if it is casted from empty or null to 0, we just set it to 2. This is our defaulting logic. For validation, we call the same function validate replicas because that's the field we want to validate. The validate replica will return an error if the replicas are greater than 5. So the output of this validate update and create and delete will be warnings and error. So when we have an validation issue, we don't return any warnings, but we do return an error message. And for our defaulting, Kubebuilder will take care of creating a JSON patch out of this spec replicas that we set here. Another thing that is worth mentioning is Kubebuilder markers that are generated by Kubebuilder for the paths or endpoints of our webhooks. So for our mutating webhook, the path is going to be mutate log example.com v1 ghost. So this is sort of the route. And for the validation, this is the route. And when we do make manifest, this will be then used to generate the manifest for our webhook. So if we look at this file, you see for registering our webhook to the Kubernetes cluster, we have those markers being mapped to YAML files. And for example, for mutation, it's called when we have create an update, and validation is called when the operations are create and update. So that's pretty much the logic. All those stuff that are set in those markers will be then translated into this manifest. Let's now move on. So we did implement our webhook logic. Now all that's left to do is to create the webhook configuration and configure Kubebuilder to take care of the rest of the config for us. We did see this manifests for registering our mutating and validating webhook to our Kubernetes cluster. Here, there's another YAML file called service, which will be the service for our webhook service. And as you can see, our webhook service, this HTTPS service or endpoint, is going to be contained by our manager. This is the same manager that contains our Ghost API, and Kubernetes API needs to communicate with this HTTP service in a secure way on port 443. We need to have the right certificate for our webhook service. What is the Kubernetes native service for managing or handling all the certificate related issues? That's called Cert Manager. And Kubebuilder, as it's used customized for basically generating manifest and patching manifest, we just need to go ahead and uncomment some parts in the customization configuration so that Cert Manager can do its job. So let's just go ahead and find config default customization and look for all the sections that are marked by Cert Manager. So let's just find this one, for example, and all the instances. So let's just uncomment this part and move to the next part. This needs to be uncommented, and the next one here, uncomment everything from here to the bottom. All right, And the next file is config crd customization, and look for cert manager. This is the only place, looks like it. So let's just uncomment this. And now I guess we should be good to go. So now we have everything that cert manager needs. Do its CA bundle injection once the right manifests are there and rendered by custom. So once we do that, let's run make manifests again. And now we need to actually have cert manager installed on our cluster. This is not something that comes with a Kubebuilder. This is like a third-party tool that we can install on our cluster. To make our life a bit easier, we're gonna add this to our make file. Let's go find our make file here and scroll way to the bottom and paste everything in here. It's saved already. So now let's do make install cert manager. And now we can see that cert manager is being installed in its own namespace. Cool. To make sure that it is the cert manager pods are running, let's just run this. Awesome. Cert manager itself also has a webhook, interestingly. But the pod that we do care about a lot is the CA injector, which injects the CA bundle into our webhook. Now we are in a good shape to create an image out of everything we have, out of our controller and the webhook logic that is going to be deployed to our manager. So let's just set this image tag and do Docker build. It's worth mentioning that I'm using this TTL-SH, which is an anonymous and ephemeral Docker registry. Super handy if you don't want to log into Docker registry every time you want to build something. It's like a perfect tool for testing purposes and for CI environments or lab environments like this killer Coda. So I'm just using it. It's super handy. I'm gonna keep the Docker build go through. One thing, it's worth mentioning that this is a lab environment, an ephemeral lab environment with limited bandwidth and limited compute resources. So your Docker build is going to take some time. Please have some patience. All right, now my build is done. And I need to do push. I push to the TTL-SH because that's the tag I've set. Now I have my image pushed and everything is ready to run make deploy. So let's do that. Now we are deploying our operator and the new image, the webhook, everything, all the new logic. Everything is now deployed. Now let's have a look at K9s. So if I run K9s and I go to, so I press colon and then look at the namespaces, I see my operator tutorial system namespace here. Let's click on it and I see that my manager is running. Good. The manager in here, which is using my TTL-SH image. Now the very same namespace, if I now look at the mutating webhooks, let's exit out of the K9s and run this command. I see I have a mutating webhook configuration and I also have a validating webhook configuration. So if I do get validating webhook configuration for the operator tutorial namespace, I see I have validating webhook configuration here as well. So everything looks good. Let's test our webhook, see if it actually does what it's supposed to. In order to test our webhook, we need to apply our manifest, right? But how can we test the defaulting logic? We said when there is no replicas set on the spec, just want to we want the defaulting logic to set it to 2. So let's do that. Let's create a namespace for our marketing team and let's apply. Let's look at our sample blog v1 ghost. So this looks good. So let's just apply this one. Let's look at the number of replicas on our ghost resource. Remember, no replicas in here, but it should be set to 2 by default. So let's get the number of replicas for our deployment. So now if I run this command to get the number of replicas for my managed deployment resource, I get that it is 2, the default that the defaulting webhook has set. And if I describe my ghost resource in my marketing namespace, I see the replicas on the ghost resource is also set to 2. Everything has been successfully deployed. Next, let's test the validation logic. Let's quickly check the validation. Let's go ahead and set the replicas of our ghost resource to something that we know is not valid, and immediately try to apply it. And we get the error denied. Ghost replicas cannot be more than 5. Which basically means that our validation is working with this message. Finally, let's have a look at our environments. Let's go look at our operating tutorial system namespace and look at the services. we see we have our webhook service in here, and if I click on my webhook service to see which pod is actually this service is pointing to, it points me to the manager, which again confirms the fact that our webhook being contained within our manager. And these are the learning resources for this lab: YouTube video, the Clear Code lab environment, documentation of Kubernetes, and the Kubebuilder docs on how to generate and work with Kubernetes webhooks. It's really awesome. Just became a Kubernetes webhooks guru. I hope you liked the video. If you did, please give it a like and subscribe to the channel. And if you have questions or any comments regarding the content, please leave it in the comments section. And don't forget to share the video with your friends who are into building operators or anything that has to do with the Kubernetes API machinery. I really appreciate it. Thank you guys. See you next time.